Hi all, in this paper we're going to talk about how to write the results section. So first of all, what is a results section? So the results section of your paper is where you describe each table of your paper in detail. Much like your literature review, the results section of your paper should be written through the lens of your research question. That is, each paragraph describing each table should not only describe the results you found, but should also explain how the results relate to and help answer your research question. So, what is a research question? Well, a research question is the question that your paper answers. For example, when I was writing my thesis, my research question was, can other litigation against a firm be used to create a more accurate measure of a firm's securities litigation risk? Another example of a research question is, how do markets react to earnings and sales surprises? So, how is the results section organized? Each paragraph in your results section should describe a different table in your paper. The first paragraph of your results section will describe the summary statistics in Table 1. The second paragraph will describe the regression results in Table 2, and so on. In the event your paper has multiple panels per table, then your results section should include one paragraph per panel instead of one paragraph per table. So these are the results that we got as a result of the how to code a finance paper from scratch video. And so this gives the seasonal random walk earning surprise, the seasonal random walk sales surprise, and so on. And for each of the variables, it gives the number of observations, the minimum, the 10th percentile, 25th percentile, and so on. Just so you note, this is for all firms with analyst coverage. And here we go through each of the explanatory variables in our model. And the number of unique firms this is for is 3,107. So for summary statistics panel A, we would write panel A of table 1 reports summary statistics about the variables in the study for the analyst forecast sample during the period 2020 to 2022 to Q1. And if you have a question about how we know this is the period, it's because this is the period that was defined as our sample period in the how to code a finance paper from scratch video. And so if you're not sure about that, go back and watch that video and it'll give you a sense. The median scaled earnings and sales surprises are all close to zero and seem to be reasonably symmetric around zero. The 3-day return for our analyst forecast sample is positive and close to zero on the median. Okay, so to get a sense of what this means, it's if we go look at the earnings and sales surprises, which is right here, they should be relatively centered around zero. And that's what is true. Because if you look, the minimum 10th percentile, 25th percentile are all negative, and the 50th, 75th, 90th, and max are all positive. And that's true for both the analyst earnings surprise and analyst sales surprise. And so sure enough, they are centered around zero. The 3-day return for our analyst forecast sample is positive and close to zero on the median. All right, so now let's go look at the 3-day return variable. And sure enough, it is at the 50th percentile, very close to zero, right? So this is 0.48 basis points. So this is about 1/2 of 1/100th of 1%. And so that is very close to zero. Thus, our sample exhibits positive abnormal returns more often than not. So because the median is positive, it means that more than 50% of the sample of 3-day returns are positive. But as we said, it's very close to zero. The size of the analyst forecast sample firms varies considerably from small firms to very large one in terms of both market values and sales. So if we go back to the market value of equity, we can see our minimum firm is about $8.79 million, and our maximum firm is 2.9 billion. So sure enough, that is a very large range from 8.7 million to 2.9 billion. Okay, the book to market and sales is actually not in the model, but we want to add it in the future. And so this actually shouldn't, it should just, there should be a period here and it's market values period and not include sales. The book to market ratio indicates that many of our analysts forecast sample firms are in the lower range of the United States population, which means that we are likely to have more growth firms than value firms. So let's go look at that. So the book to market, as you can see here, the bottom 50% of the distribution in book to market corresponds to about 0.36, 0 to 0.36 of the book market. And if you remember, the bottom third book to market, those are assuming they don't pay in the top quartile for dividends. Those firms are growth firms. So basically, the bottom half of our sample is growth firms. And then if you look up here, the 75th percentile um, to the max, this is, or the 67th to the max. So this is basically the 67th to 1. This is the top third quartile. So this is typically what corresponds to a value firm if they pay in the top 25th percentile of the dividends. So basically, the top 25% of our sample corresponds to value, and the bottom 50% corresponds to growth, roughly speaking. Okay. So we have many more growth firms than we have value firms. This is probably due to the restriction on availability of analyst sales forecasts. So then the question is, why do we have so many growth firms? Well, if you recall, our sample is made up of all firms with analyst coverage. And so it could very well be in the 2020-2022 period that this is due to the availability of analyst sales forecasts, which are more likely to exist for growth firms than value firms, possibly due to investors' interest in growth firms during the period. And then if we go look up how growth did as a factor, it probably did very well from 2020 to 2022. And then, as we know, in January to March of 2022, value started to do better. But for much of the sample, growth was doing better, which kind of explains why analysts may want to cover those companies. Okay, so now we're looking at panel B. And so for panel B, this is summary statistics for value firms. And again, it's only 590 firms. And then panel B also includes summary statistics for growth firms, and the number of firms is 1,301. So panel B of table 1 provides separate summary statistics for value and growth firms in the analyst forecast sample during the period 2020 to 2022 Q1. As can be expected, value firms have sales surprise have value firms have what do we say here? It's probably value firms have smaller sales surprises than growth firms is the guess. Um, so this is the sales surprise for value firms is 0.69 at the 50th percentile. And then what about for growth firm? Okay, 1.51. Okay, so the growth firms have much bigger, so value firms have smaller sales surprises than growth firms. Value firms are also smaller in terms of market value of equity than growth firms. All right, so let's look at the market value of equity for growth firms is about 4.9 billion, and then for value firms it's 1.7 billion, as you can see right here. So sure enough, the growth firms are bigger than the value firms, but value firms have higher book to market ratios by construction and also higher shareholder equity than growth firms at the 50th percentile. And as we can see, let's look at the book to equity or book to market for growth firms at the 50th percentile is 0.13, and the book to market for value firms at the 50th percentile is 0.92. So these guys have much, much bigger book to markets than the value firms. And this means that even though the market value of the growth firms is bigger, the value firms actually have more shareholder equity than the growth firms. In particular, I think these have about $1.5 billion in book value, right? So in shareholder equity, the value firms have about 1.5 billion in shareholder equity. By comparison, the growth firms have about 600 to 700 million in book value. And the way that we calculated that is by multiplying 0.1355 times 4.9 billion. And that gets us about between 6 and 700 million. And so sure enough, um, the given that the value firms have shareholder equity of about 6 to 700 million, and the value firms have shareholder equity of about 1.5 billion. So the value firms have much bigger shareholder equity at the 50th percentile. It should be noted that the analyst's forecast subsample has twice as many growth firms than value firms. This may indicate a self-selection bias where analysts prefer to provide revenue forecasts for growth firms for which revenues may be a more important factor in the valuation. Given we only have the sample of firms with analyst coverage, we do not know the extent to which the distribution of growth and value firms in the subsample with analyst coverage is consistent with the distribution of growth and value firms in the entire sample of firms on CompuStat during the same period. And just so you know, to calculate these numbers for the entire sample, what we would want to do is go back and create a different sample, which did not include analyst forecasts in the how to code a finance paper from scratch paper. Okay, so now let's look at our Table 2 OLS Regression Model 1 results. So first of all, what we did is we regressed the 3-day return on the quarterly earnings surprise. And so the quarterly earnings surprise is measured by actual earnings minus expected earnings divided by the standard deviation of the analyst estimates for the quarterly earnings. And we can see that basically a one standard deviation increase in the, or one standard deviation beat of analyst estimates for earnings corresponds to about a 0.08 basis point 0.08 of a basis point 3-day return. So like if you beat the EPS estimate by one standard deviation, it corresponds to 8/100ths of 1 basis point. So that is actually quite small. Similarly, in this should read Model 2 instead of Model 1 because this is the model Table 2 OLS Regression Model 2. A one standard deviation beat in the quarterly sales estimate SUE score corresponds to a 5/100ths of 1 basis point. So let's look at the writing. So Table 2 reports the results of regression equations 1 and 2, where the dependent variable is the 3-day return and the independent variable are the earnings surprise in equation 1 and the sales surprise in equation 2. The table reports results for the analyst forecast subsample in panel A. So we started out by just describing what Model 1 is, what Model 2 is, and then what the sample is. In a follow-up version of this paper, we plan to include a panel B that provides results for the analyst subsample, but using both the seasonal random walk and the random walk models to proxy for market expectations. In particular, we will regress the 3-day return variable on seasonal random walk for earnings in the first specification, and we will regress the 3-day return variable on random walk for earnings in the second specification. Consistent with prior studies, including Erdemer et al., the earnings surprise in panel A is positively associated with adjusted returns. And in this case, we're using raw returns. And so this should read raw returns instead of adjusted returns. And the coefficient is considerably smaller in magnitude than the coefficient on earnings surprise in Erdemer et al. And Swaminathan and Whiterup, 1991. In Table 2, Panel A, Model 2, we find that the sales surprise is positively associated with the 3-day return. Consistent with prior studies, including Erdemer et al. 2003, the coefficient on the sales surprise is considerably smaller in magnitude than the coefficient on sales surprise in Erdemer and Swaminathan and Whiterup, 1991. So we basically find that the coefficient on the sales surprise is smaller than in Panel A than the coefficient on sales surprise in Erdemer, 2003. And so one thing we would want to discuss is, well, why do we think it's smaller? And so first of all, Erdemer et al. Uses a 1994 to 2001 sample, and we use a 2020 to 2022 sample. And so we're fundamentally looking at different market periods and different time periods. And so that could help explain why the coefficient on our sales surprise is smaller than the coefficient on Erdemer's. So in panel B, which regresses 3-day returns in the seasonal random walk of earnings and 3-day returns in the random walk, we expect to find that both the earnings price and the sales price are positive and have large coefficients for the seasonal random walk. For the seasonal random walk, we expect to find that the coefficient on both earnings price and sales price are not statistically significant because the analyst subsample is composed of 2010 value firm observations and 4,208 growth observations. Given the large number of growth observations, we do not expect the seasonal random walk specification to be meaningful, as the growth firms will likely experience very considerable growth. So what we're saying here is basically we think that the seasonal random walk measure is going to be very noisy because it compares 4 quarters ago to this quarter. And given half of our sample is made up of growth firms, we think that those are going to be huge increases. And so if the denominator is huge, but those, the market largely anticipates um, those huge movements because they've, seen the growth in sales over the last 3 quarters, then there might be a small, 3-day return following the earnings announcement, and yet there will be likely for most of these growth companies a huge increase in sales. And so that's why we expect um, for seasonal random walk the coefficient on the earnings and sales surprise to be not statistically significant. It's likely to be very small. All right, in table 3, we're regressing 3-day return on a value dummy, quarterly earnings per share SUE surprise is basically earnings surprise, and then earnings surprise interacted with the value dummy. And then in table 3, model 2, this should read model 2 right here. We're reading, we're regressing 3-day return on value dummy, quarterly sales surprise interacted with the value dummy. Okay, so table 3 reports the results of the 3-day return regressed on the value dummy, earnings surprise, sales surprise, earnings surprise interacted with value dummy. Okay, and the sales surprise interacted with the value dummy variable, along with the sales surprise, and the sales surprise interacted with the value dummy variable. So in the first sentence, what we're doing is we're basically introducing what model 1 is, what table 3 model 1 is, and what table 3 model 2 is. The table reveals that in the earnings specification, value companies have a higher intercept than those of growth companies, consistent with higher 3-day returns of value companies, although not statistically significant, different from 0. So this means the value companies have uh, um, higher intercept. So that means this value dummy is 0.0079 if it's a value firm versus a intercept of 0.0032 if it's a growth firm. So basically, if it's a value firm, we would add these two together. So 0.0032 plus 0.0079. So this would come out to about more than 0.01. So basically, the coefficient on the intercept for value firms is about 0.01, and the coefficient on the intercept for growth firms is about 0.003. So this means that basically value firms typically have, excluding the sales surprise, excluding what happens with the sales surprise, and let's say the sales surprise is 0, the value firms still have, basically about 3 times as big return, even if there's no sales surprise. And let's see what it looks like for earnings. So here again, yeah, the value dummy is positive, and so this would be about more than 3 times, almost 4 times it looks like, um, return for value firms if there's no earnings surprise. So if they meet exactly and this is 0, these two are 0, the stock is going to move up about 1 basis point. For value firms, it'll move up about a quarter of a basis point for growth firms. So sure enough, in both the earnings and the sales specification, value firms have a higher intercept than those of growth companies, consistent with higher 3-day returns of value companies, although not statistically significant. Okay, in this case, it is statistically significant. So the table also reveals that in the earnings specification, the earnings response coefficient of value companies is significantly lower than of growth companies, indicating relatively greater importance investors attach to earnings of growth companies. So if we look here, this basically means that, so this is the coefficient for all other companies, and this is the coefficient for value companies. So it's 0.0009 minus 0.0009 for value companies. So this is close to 0. The coefficient is close to 0 for value companies that beat earnings by 1 standard deviation. By comparison, the 3-day return for firms that beat earnings by 1 standard deviation for growth firms is 0.0009. So this would be 9/100 9/100ths of one basis point. So what this is telling us is that value firms have a 3-day return of equal to about 0 if they beat earnings by 1 standard deviation, and growth firms have about 9/100ths of 1 basis point if they beat earnings by 1 standard deviation. And so basically, this is saying that value companies are less responsive to earnings beats than growth companies. So, and by the way, if you have questions about interaction terms, you can go back and watch our video how to interpret an interaction term. In the sales specification, we find that sales surprise is significantly less strongly associated with 3-day returns for value companies than for growth companies. And so, if you think about that, so if the sales surprise is significantly less strongly associated for value companies than for growth companies, that means the interaction term here on sales will be negative. And sure enough, it is. Right? So the response for um, value companies is about 0.0002, and because it's 6 minus 4 here, and which is, so it's 0.002 for value companies, and the 3-day return in response to 1 standard deviation beat of sales for growth companies is about 0.006, 0.0006, right? So means that value companies are much more responsive to sales beats than, sorry, growth companies are much more responsive to sales beats than value companies. Yeah, this is consistent with our expectations that investors attach more importance to sales growth of growth companies than for value companies. In a future version of this paper, we intend to test whether the results obtained are consistent with the results in the entire sample, where analysts' forecasts are not necessarily available. And so, as you recall, in order to do that, what we'd have to do is go into the how to code a finance paper from scratch, select the entire sample, not just those with analysts' sales and earnings surprises, and then we would use seasonal random walk and random walk to run that. And we regress 3-day returns on seasonal random walk, 3-day returns on random walk. The above results indicate that market reactions are different between value and growth. Market participants seem to place more importance on the sales surprise and earnings surprise for growth companies than for value companies. Okay, a few reminders. Check to see how the results that we found compare to previous literature, including Erdemer et al. 2003 and Swaminathan and Whiterup 1991. Consider rerunning the regressions with the entire sample and not just for firms with analyst forecasts. In those regressions, it would be 3-day returns regressed on seasonal random walk earnings, seasonal random walk sales, and 3-day returns regressed on seasonal random walk, just random walk earnings and random walk sales. Also, check the value growth subsample of the entire sample. Check to see how the results that we found for the analyst subsample compare to the results we found for the entire sample. Consider rerunning the exact models that we run in Erdemer et al. 2003 to get a true apples-to-apples comparison. So this concludes the video. I hope you guys enjoyed it, and I look forward to seeing you in the next video. Take care.